Dear all, today's topic of discussion is domain or domain of a function. First of all, we know that what is a function? Function is any relation, or you can say that function is a machine from a set D to a set Y. Here, we often use this set D as a domain of F, or we said dom F. Okay, what does it mean? What is domain? Domain for a layman person, what is a domain? Domain is consisting upon domain is a set of points where f function f do not vanish, or you can say that f is defined, or you can say that f is not undefined. Actually, we have to learn this thing. F is not undefined, or vanish, or defined. Okay, what does it mean by undefined? Or vanish? All those values of x where x come from D, when you put this x in f of x and f of x get any one of the following form. What are the forms? For example, infinite over infinite form. This is also undefined form. Or if we get the form like infinite over infinite, then we say that f of x is vanished here at that x. If we put x and f of x get this form 0 over 0 form, this is somehow undefined. I will describe something about how this 0 over 0 form is undefined. Something over 0 specifically, we say that this is also known as, we can say for a moment, this is undefined. In this system, in this course, or in this level, we say that something inside square root is negative. Then we say that this is a complex, or we can say that this is out of the domain. This is another point of discussion, because our restriction is that D can be or Y can be set of real numbers. So this is not a real number. So that we can say that this f of x is vanish over here if we get something negative inside the square root. Okay, there are some other things. For example, if you see that 0 time infinite is also kind of undefined. Something raised to power infinite, 0 raised to power infinite, infinite raised to power 0. These are also undefined forms. There are several other forms, but our topic of discussion is related to some limited extent. For example, this one, we will discuss these type of defined and undefined forms, right? So at this level, we are going to ignore these things. So any element x from Z D where f of x get any any one of the following form, we say that x is not from the domain of the set F. For a moment, I will give some examples. Okay, what are the examples? First of all, example 1. This example is coming from direct from the Thomas calculus, exercise Thomas calculus, exercise 1.1, question number 1. Okay, find domain of this function f of x equal to 1 plus x squared. Okay, here d set, what does it d mean? I already described in my previous lecture that set D is actually set of real numbers, and set of real number is consisting about minus infinity to plus infinity. You can put anything from this set, and we have to limitize this set R, where this f of x is defined or undefined form. So put any number from this interval in this f of x. You have to take x from this set and plug this x in f of x and see where f of x get or attain any one of the following form. So there is a simple rule: choose any element, put in f of x, and check the form of this one. But I will give you a trick. See, first of all, you see that these functions are in the rational form. These three are in rational form. Okay, rational form mean f of x is in the form of p of x over q of x. These kind of functions are known as rational functions. Okay, and this kind of fraction is this is a fraction form, or you can say that is a rational function. So first of all, check the type of this function. Here this is p of x and this is q of x. See, whenever you put x, this one cannot be changed. If there is nothing in the denominator, then there is a 1. So this 1. See, when you put x in any x in this f of x, this 1 cannot be changed. For example, if we put x equal to 0, it will be 1 plus 0 square over 1. If we put 1 plus 1 square over 1. If we put x equal to 2, 1 plus 4 over 1. This 1 is not changed when you change value of x. So this 1 is constant. So this 1 cannot be infinite. This 1 cannot be 0. This 1 cannot be 0. Mean say that f of x is not any, we cannot get any form from these three for any value of x. Okay, mean you can plug any x in this f of x, and this f of x will not vanish in the form of infinite of 0 over 0 or something over 0. So you can plug any x from this set D. So there is no restriction. Lastly, see, there is a square root, but our f of x does not contain any square root. So whenever you put x, negative, positive, whatever x, so this will not get the form of square root of some negative number. So mean you can plug any x from this set R in this function, and this function will not vanish. So we cannot find any x where this function is undefined. So we say that all real numbers are the domain of this function. So domain of this function f1, say that this is f1. Domain of this function f1 is set of real numbers, or you can say that this is interval form, or in descriptive method x such that x belongs to set of real numbers. So this is the domain of the set. Okay, see, f2 fx. This is question number 2. This is question number 2 of the same exercise. 1 minus square root of x. See, leave this thing. Check either this f2 is a rational or not. This is not a rational function. Here denominator is strictly 1, so we cannot get any one of the from these three forms. So there is a chance of this thing. If you put x any negative x, so then this function will vanish. No, please be specific. Mean this function will vanish if we have square root type function, and this function will vanish when we put something negative inside the square root. So mean we have to check that inside of square root, what is inside of square root. Inside of square root is x, and x should not be negative. Mean it can be 0 or positive. So this is a restriction. We cannot plug anything which becomes negative inside the square root. So if you see that we cannot minus 1, minus 2, minus 3, minus 1.1, minus 1.2, minus 100, whatever. If we put square root of minus 2, it will be a complex number, and this is outside of the domain or range of the set of real numbers. So this function, domain of this function is all real numbers except negative. You can see that if you have a real line, this is 0, and so on. X is greater or equal to 0, greater or equal to 0 from right hand side. So all real numbers including 0 and positive real numbers are the domain of this function. So you can see domain of this function is in the form of restriction. This is not of consisting of whole real numbers. So you can say that we can write R over here is positive. Positive means this is not including 0. If we have to include in 0, then we have to write in this form R. You can say that 0 to plus infinity R. You can say that x, such that x belongs to real numbers and x is greater or equal to 0. These are the domain of the F2. Okay, see question number 3 as an example of exercise 1.1. If we have a function f of x, square root of 5x plus 10. Again, this is not a rational function. Here denominator is 1, so these three forms cannot be obtained by putting any x in this capital F of x. So there is one chance that if we plug anything which is negative, then the square root will becomes a complex number, and we will destroy our function. So we have to plug anything inside the square root. Inside the square root is this whole function. So we have to plug this whole function positive, non-negative in this one, and find value of x. What will be x? This is an inequality, so this will be greater or equal to minus 10, and solve for x. X will be greater or equal to minus 2. Mean you can plug anything, any real number greater or equal to minus 2. See this one. This shows that x can be equal to minus 2, x can be greater than or equal to minus 2. So this interval contains all the values. So if you see that domain of this F1 minus 2 to plus infinity are set of all real numbers excluding minus infinity to minus 2 are, you can say that x such that x belongs to a set of real numbers and x is greater or equal to minus 2. If you have any confusion on any number, either minus 2 is the part of this domain or not, so just plug that number in this function. See 5 into minus 2 plus 10. There is another confusion among students that this is minus 10 plus 10. This comes square root of 0, and square root of 0 is undefined. No, square root of 0 is defined, and that is 0. So if you have any confusion, just take your calculator, plug that number, and execute that function. If there is no math error, then that is the domain also. That number is the domain of the function. Okay, there is another question number 5. I am ignoring question number 4. Question number 5. See, there is a function f of t 4 over 3 minus t. Now this is a rational type function. This is something over 0. So we have to avoid that this cannot be, this should not be any one of the following form, and the form will be something over 0. So we have to avoid this situation. Something over 0. So we have to check when this 0 comes. See, this will be 0 if 3 minus t comes 0. So when will this happen? When t is equal to 3. So if we plug 3 over here, then this function will be vanished. So we have to avoid putting t equal to 3. Or you can say that domain of this function is all real numbers except 3. Or you can say that if we have real line, one, 2, 3, 4, up to so on, minus 1, minus 2, up to so on. So every number is the part of this domain except 3. So this cannot be part of the domain. So minus infinity to 3, okay, and 3 to plus infinity, okay. Every member of this set is the part of the domain except 3. We cannot plug 3. So you can say that this will be minus infinity to 3. Excluding 3, this means we are not including 3. From 3 to plus infinity, same lines, 3 is also not the part of this domain. You can say that in the descriptive method x such that x belongs to a set of real numbers and x cannot be 3. Now I have an exercise for you. So please guys check this function g of t and exercise, and check either domain of this function is, what is the domain of this function? I will give you an answer, but you have to verify that domain of this function will be all real numbers except minus 4 and 4. Okay, wish you best of luck. This is the topic of the today's discussion, and we will discuss graphs and range in our next lecture. Take care.